Well, good morning. So I'm here to talk to you about scenarios. So, what are scenarios? Well, they're an organized set of plausible future conditions and situations that can be used to focus and organize model simulations. When we're talking about model simulations, we're talking about our region-wide simulations of loblolly pine growth and the land base of loblolly pine and how that relates to carbon sequestration and nitrogen use. So these are projections, and there's some reasons why we need scenarios. You can think of them as a framework. Why do we need this? Well, because the future can be a bewildering situation, and we need some way to put our work into context because there's so many of us doing so many different things, and we need sort of an organized framework to make that happen in a way that allows us to communicate our findings in a rational way. Now, if you think about the future, one way to start thinking about the future is to think about the past. So let's go back to 100 years ago, 1914. And it's essentially equivalent to what we're going to be doing in the future to think, okay, 1914, let's project what it's going to be like in 1930. And then let's project from 1914 to 1950, 1960. Mid-century. Then let's project what it's going to be like in 2000. Those are the kinds of things we're talking about. If you think back on the changes that occurred in that century, how can you possibly predict the future? Well, you can't predict the future, but you can put together a way of essentially a framework to reach the goals that we're talking about in PINEMAP by assessing how much it's going to take in the way of change or modification, etc., to land and productivity and perhaps policy issues, so that if we want to meet the goals of PINEMAP, we have a roadmap to do it for the future. And what are those goals? Well, the one I'm going to talk about today has to do with increasing carbon sequestration. You've heard about that already. The first goal is to try to increase carbon sequestration in the region in loblolly pine plantations by 15% in the year 2030. But PINEMAP is going to go farther than that. And so we're going to use scenarios to evaluate carbon sequestration later in the 21st century as well, mid-century and end of the century. Okay, one of the things that was really nice about Ryan's presentation is that he described one of the 4 key components to the PINEMAP scenarios. I'll get to his in a minute or two, but they're basically what we've done is we've simplified and condensed a lot of information into 4 different aspects that need to be considered. So when we're talking about these things that I'm calling essential components, each of these essential components has embedded in it a great deal of information. And I think Ryan just gave you a great illustration about one of those. So the first one I'm going to talk about, though, is land use. So you think about the future, well, what could happen? Well, it could increase, decrease, or stay the same in terms of the land base that's in loblolly pine plantation. And this is just an example of what could happen in the future. The darker colors here are indicating a loss of loblolly pine land and forested area, and the reason for that is because of urbanization. And so, how much land is available for plantations is really a function of economic activity, and it's something we need to consider. Okay, the second essential component is productivity and management intensity. So we have a lot of options when it comes to changes in productivity. And again, remember, these embed so much information. So when we're talking about this, we're talking about changes in genetics. We're talking about on-site manipulations. We're talking about mid-rotation decisions. We're talking about fertilization and weed control. We're talking about all sorts of things we can do to increase the yield or change the yield, depending on our decisions. And also, this also embeds on-site carbon management. So you have that going on as well. So think of these things again as having a huge amount of underlying information within them. Okay, now when we talk about, so far we've been talking about productivity this morning, it's come up a number of times. Remember, carbon sequestration goes a little farther beyond that. There's definitely a link between productivity and sequestration, but the amount of carbon stored depends on lots of things. So what we've been sort of talking about is right here, this is the size of this forest base, but we also have to consider how much carbon is being used for harvesting, sawmill operations, how much material is available in stored material, in wood products, how much is available in paper, what happens in these pulp and paper operations in terms of how much carbon is used for fossil fuel exchange, and then what the sort of the final end of these things is. So actually this little diagram here, which has a group of carbon sinks listed across the top here, and then a group of additional emissions that need to be assessed, is really, again, a little bit of a simplification. There are extra parts here which don't show up in this diagram, but it gives you an illustration of all the things we need to think about with carbon sequestration that go beyond just talking about productivity. And we will. Okay, the third is the one Ryan was talking about. I'm calling it environment. It's climate plus CO2, and that's the only reason for calling it that. So climatic conditions we're interested in are projections of precipitation, temperature, and atmospheric CO2 concentrations. All of them have major effects on growth and productivity. So these diagrams are showing the CO2 response, and you can see the RPC 8.5 and the RPC 4.5 radiative forcing factor relationships here, and so most of this is CO2. But there are other things here, methane, chlorofluorocarbons, things like that. So these are RCP as representative concentration pathways. And so the RCP 4.5 and 8.5 have essentially the same range early on. And I just want to point that out because that has an effect on our near-term scenarios, the ones going out to 2030. But notice after that 2030 period that they diverge, and that's another important consideration. And I'm just illustrating that we have issues of drought. This just is showing one point in time, drought increasing, drought decreasing regionally, and the bottom one is just showing the number of days per year that can be excessively hot, meaning days over 90 degrees. It's another consideration that come out in these climate projections, downscaled for the region, indicating that it could get a lot hotter in the region. The last of the four components is disturbance. Now, there are all sorts of disturbances, as Marshall said earlier today, that are affecting forests. And so these need to be considered because there are insects, pathogens, fire and wind, which it should say fire right there, and wind represented down there, which are affecting productivity regionally. In other words, the total yield across the region. This is the most uncertain of all of the four key components that we know about. It is highly variable. So, with those four key components, what I'm going to illustrate to you is that we need to select certain types of scenario combinations to use because of the complexity involved in all of the possibilities for the future. And so I'm going to show you those scenarios in a very simple way this morning, and that is just by showing that each scenario can have a combination of levels. And those levels are 1, 0, 1, 2, 3. Okay, so a decrease in a component would be negative, no change would be 0, 1, 2, and 3 would be levels of increase. Now, where do these numbers come from? Well, they come from our knowledge base. It comes from models that already exist. Good example are the models we just saw for downscaling climate. That's where information is coming from for change in the future in the environment. But it's also coming from expert opinion. We have a lot of excellent scientists in PINEMAP, and we have a lot of excellent scientists in the region as well that we are tapping into to try to put bounds on the scales that we're talking about with increasing 1, 2, 3, or decreasing. Okay, let's get to some of these scenario combinations. So we're talking about the near term now, 2030. That's 16 years away. Want to increase carbon sequestration in loblolly pine plantations in the next 16 years by 15%. How do we do that, and what factors are important? Well, you may remember from those climate scenarios I showed you that the two main climate pathways we're talking about really are essentially the same. So we can use a consistent environment. Okay, so that takes environment out of this equation. We use a single one. Disturbance. For right now, I'm just going to illustrate what happens if we assume there's no change in disturbance over this next period of time to the year 2030. Okay, so what do we need to think about? Well, we need to think about land use. Land use going to decrease? Is it going to stay the same? Is it going to increase? Similarly, across the region, is productivity going to increase or decrease? Well, probably the one that we should be looking at the current time, based on feedback we're getting, is that probably land use is not going to change too much in the next 16 years. And so that allows us to then focus on productivity. What happens if productivity stays the same? Can PINEMAP goals be reached? Well, what happens if it decreases? What does that mean for carbon sequestration or increasing? So those would be reasonable scenarios to use. So that's 4 out of 12 here that could be used. But then, of course, there are other combinations to think about. Well, what happens if land use goes down? In other words, land is taken out of production for loblolly pine plantations. What if it goes up? Well, there are ways of restricting our assessments, in this case, considering productivity is 0 or no change. Well, but then you might say, well, we probably need to look at a little bit more. So that brings us to a couple more scenarios that might be used. So out of these 12 scenarios at the present time, I'm suggesting we might be using 9 or 10 of them for this. And that's an indication of how complicated this sort of thing can be. And that's why at this point in time, we are working hard to try to restrict the number of scenarios we're running on a regional basis to a much more limited set because of how complex this gets. Now, let me illustrate that point a little bit further here by showing you what happens with the same scenarios if we say, oh, but disturbance might increase. Well, all of a sudden we've got 24 scenarios to deal with. How do you deal with that much complexity? Well, you have to make decisions. And so I'm suggesting perhaps the ones we would use out of this 24 just revolve around these 4. Baseline, no change. And then if productivity increases. Now let's compare that to a baseline with an increase in disturbance, and then an increase in productivity and an increase in disturbance. Those would be potential scenarios. Now, I'm not the one to make the decision on which of these we use, but that's the approach we're going to take. We're going to build up some rational reasons for the types of projections we're going to make for the future and put boundaries on them using these scenario combinations. Okay, now when we get out a little bit farther, things get more interesting. Or more complex, depending on how you look at it. Because we really, for the mid part of the century and the end of the century, we do need to consider changes in the climate and CO2 concentrations, and we do need to consider increases in disturbance. So there are, I believe, 16 combinations in this, and this particular scenario set is just assuming that land is constant. We've got the same amount of plantation land as we had before for the rest of the century. And so then what we're really focusing on here is how does productivity change, and how is that related to the environment or the climate, and how is that related to disturbances. And so in order to understand something like that, well, we have to look at this over a wide range of conditions. As I said, there's 16 possibilities in this particular set, and that's because we have environment change. In other words, the climate will be changing as the century goes on. And so it might change a little bit, that's the RPC 4.5, or it might be changing a lot, that would be RPC 8.5. The good news is we have nice bounds on those particular parts of the model. We also have information about the other things, which does help us understand how we're going to go. In this particular case, we're assuming one level, just one level of disturbance. Again, it's a matter of complexity, and so it's a matter of deciding which of these scenarios or which of these storylines, if you want to think of it that way, we're going to be using to describe to other scientists and describe to the general public and describe to forest managers what it will take to increase carbon sequestration. Okay, this just shows those two levels of disturbance. Oh, before I finish with that, let me just mention, I briefly touched on it, but wanted to indicate to you that although I've tried to describe this in very simple ways, of course there's a lot of information embedded in each of these things, but we actually know quite a bit of information at this point. So it's not a hopeless situation at all. For example, Ryan just described part of what we know about how the environment's going to change in the future, how the climate's going to change. So we have good bounds on that. We also have good information from economic models about how, and information from the past about how land use could change. So we have some bounds on the numbers we're talking about here, which will be very important. Productivity, we have a lot of information about how much we can change productivity. And so we can use that information to inform this range of conditions I'm talking about. For disturbance, we are starting to get more information all the time about this. There are some good models in PINEMAP related to disturbance effects, and there are also groups outside of PINEMAP which have information on the range of the degree of disturbance that we might expect in the future. So the point is that in the near term, we will be refining those scenario components through expert opinion. That includes the models that our various scientists in the region have developed to put bounds on these numbers and to allow us to make those decisions about which of these components we think are the most important. Otherwise, and the reason for doing that is otherwise you would just have a bewildering array of possibilities depending on what each individual scientist pick. Then we'll be making our model runs to establish how much carbon can be sequestered under different conditions, and there's a lot of what if here. The what if is not just the most certain pathway, but it's also what might happen in situations that you're not quite so sure about, but could happen. For example, what if there's a change in policy which drives a carbon market, or which drives an increase in planting of loblolly pine? What would that mean to carbon sequestration? That's the sort of thing we're talking about as things that have some potential but not necessarily are the most likely. Okay, after we've done that, then we're going to be developing recommendations for optimum management activities to increase carbon sequestration for different types of landowners, because industrial landowners will have a different view of what they want to do and what they can do compared to non-industrial landowners. And so we will end up with a group of management alternatives that will potentially push the region forward toward gaining more carbon in pine plantations from a variety of different outcomes. Okay, that could be from wood that's taken off-site. It could be from management of carbon on-site. There's all sorts of things that can be done. And then you may remember that Tim mentioned early on that there is nitrogen involved in PINEMAP as well. And so there'll be a series of scenarios as well, which will be more limited. But those scenarios will involve how we can manage nitrogen, and as Marshall indicated earlier, whether or not managing nitrogen is going to be by managing nitrogen, I mean limiting nitrogen as our best option. Perhaps we would just need to be more efficient or effective in how we utilize nitrogen on site to get that increased carbon sequestration. So those are the scenarios in a nutshell. Thank you.